So for those of you who are unaware, PIBBSS is the Principles for Intelligent Behavior in Biological and Social Systems. Sort of goal of the group is studying AI safety with the hope of learning valuable insights from the wide range of disciplinary and interdisciplinary work in the sciences. So the speaker series in particular, our goal and hope is to bring researchers working in areas adjacent to AI safety, so not necessarily in AI safety, to discuss their research with the aim of developing a resource for AI safety researchers to better see the connection between their work and work going on in other disciplines. So today we have Andrew Little. He was very kind to join us. He's an associate professor of political science at UC Berkeley. His research uses formal models to explore the causes and political consequences of biased beliefs. And so today he's going to attempt to give us a unified theory of rational and biased beliefs. So I will turn it over to Andrew, and yeah, thanks for joining us.
Great, thank you so much. So I think it'll be helpful in a presentation like this if there's confusions to just interrupt me with questions. So I trust you to figure out that technology. So either if you have the ability, feel free to jump in, or if you maybe throw something in the chat or Q&A, then Zach or someone else can interrupt me to make sure I get to that. So I gave this talk a somewhat grandiose title, but hopefully you'll see what I'm trying to do is obviously going to be a little more modest than what the title states. But I thought for kind of a different audience, I could get away with that. So what are we going to be doing here? So I want to think about the right ways to define what it means to have correct or biased beliefs. And so if you're a political scientist like me, I work a lot with economists too, the standard way to think about what it means to have biased beliefs or correct beliefs is to ask whether people update their beliefs via Bayes' rule. So I'm sure this is reviewed for most people. Bayes' rule provides a really simple and in a sense mathematically correct way to update our beliefs when we get new information. So just to, again, I'm sure you've all seen Bayes' rule before, but just to start to introduce some of the notation I'll use in the talk. If we start with a prior belief before we get our new information about any random variable, think of this as, how corrupt is the politician in my country is one that in my research area we think about. And then we observe some signal, maybe I read a news article, and the way Bayes' rule is going to tell us how to incorporate that information is to say we have to define what's called a likelihood function, and I'll use f of s given omega for that. If the possible signals that we can observe are discrete, then this likelihood function is also just going to be a probability distribution function that says for all possible omegas, for all possible levels of corruption of the politician, what's the probability that I would observe different news articles? So likelihood function is just this in a sense, just a conditional probability. And we need to kind of define this for all possible levels of corruption, all possible news articles we might see. And so again, familiar, I'm sure to all you, we can get Bayes' rule just by essentially rearranging the definition of conditional probability. So we can write, the probability of omega and s as either the probability of s times the probability of omega given s, or we can do our conditioning in the reverse direction, the probability of the signal given the truth times the prior belief about the truth. And so, by rearranging that, we can solve for something called the probability of omega given s. And the reason why that's an object we care about is you can think of that as my belief about what the truth is conditional on the information I got. So how do I go from a belief about how the world works to a new belief about how the world works after observing a signal? Bayes' rule gives a simple answer to that question. So is Bayes' rule a good test or a good definition of rationality? Well, the good news here is that Bayes' rule is a very straightforward way to define rational updating. It literally just follows from conditional probability and division. The bad news, though, is that, well, first, Bayes' rule only tells us how we should update our belief. So if someone, comes to me and says, I believe that lizard people run the world, I can't really say that they're not using Bayes' rule because I don't actually know how they're updating in response to any new information. So Bayes' rule, in a sense, is it's like a slice of rationality. And we can say, under some circumstances, how should you respond to new information? But another way to put that is Bayes' rule tells us nothing about what the right prior belief to have is. right? So someone could come to me with a belief that seems really crazy, but without knowing the information that led them to that belief, I have no idea if they reached that by using Bayes' rule. Another related problem, which I think is actually kind of even deeper, is that Bayes' rule also doesn't tell us like what the right likelihood function is to have. So going back to my opening example, if I read a news article which gives some new information about whether the president might be corrupt, it's not necessarily easy to translate those words into a likelihood function, or at least it's not obvious how to do that. And so if maybe different people read this article different ways, it may not mean that some of them are Bayesian and some of them aren't. It could just mean that they translate those words into a different likelihood function. And so maybe everyone is like updating via Bayes' rule, given their prior and likelihood, but how that actually translates into beliefs and discourse and disagreement is not particularly clear. So that's Bayes' rule. So there's another way to think about rationality. And so now we're veering more into a world where I'm sure there's a lot of people on this call who actually know a lot more than me. It actually comes out of information theory and statistical mechanics. So in words, this definition of what should rational beliefs be is that we should aim to be as uncertain as possible, subject to the information we have. So this has a really sort of rich tradition of famous old scientists from Laplace to Shannon to Jaynes of finding different ways to formalize this idea. But first, we should point out that it's like not obvious how to formalize this idea, right? So what does it mean to be as uncertain as possible? What does it mean to have your beliefs be subject to the constraints of the information you have? And so there's a really wonderful insight from Jaynes, this 1957 article, which shows how we can use some ideas from information theory in order to formalize this notion of rational beliefs, right? Which again, like might seem very different than Bayes' rule, and part of like the twist at the ending is we're gonna see that these two things can actually be reconciled. So just like with Bayes' rule, I'm sure a lot of you are familiar with this, but just to get you used to some notation, start to think about how I'm going to interpret these quantities. So first to get at this idea of how to measure uncertainty, Jaynes, building on Shannon's famous paper, says we should think about the uncertainty that we have as the entropy of our distribution. So if we have any discrete probability distribution, before I was talking about omega is our random variable. I'm going to say that can take on n possible values. I'm going to use i's to index those possible values. So this is just a discrete probability distribution, pi. And so the entropy of that distribution is essentially just a function of the probability distribution. And one way to write that is just the negative of the sum of the probability of each possibility times the log of that probability. Or another way to write this is we want to sum up the probability of an outcome times the log over 1 minus that probability. And where the key starting point for Shannon's article is to think about this log of 1 over pi as how surprised you would be to learn that the truth is in fact I, that state it ends up being the truth. So think of this as I'm going to learn what the truth is in a second. We're going to define log of 1 over pi as how surprised I am by a particular revelation. And then this entropy quantity is saying, on average, how surprised am I going to be? Right? So I'm averaging over the possible surprises, weighting them by how likely they are. Right? So why is this a nice way to think about surprise? Well, I think like the initial part of the Shannon paper gives an axiomatic characterization. I'll just give you a very loose verbal intuition. So first, you can think that like a high probability event, something which is almost certain to happen, that pi is going to be close to 1. So log of 1 over pi is going to be a bit over 1. So it's going to be something close to 0. On the other hand, a low probability event, if pi is close to 0, we're going to be taking the log of a big number. So that's a way to capture the idea that possibility I is very surprising. Right. And so on one extreme, so if like we know for sure what the truth is going to be, if we know that state 3 is the one that's going to happen for sure, this entropy formula is going to return 0, meaning in a sense there's no uncertainty because we know what is going to be revealed. So that's maybe how we minimize uncertainty. So how do we maximize uncertainty? So a way to think about that in terms of a maximization problem is to ask what's the proper probability distribution P. So only subject to the constraint that all of my PIs are positive and they have to sum to 1. What's the distribution that maximizes entropy? Well, I mean, we could like walk through, it's like a 3-step proof to show that the answer to this is a uniform distribution, right? So placing equal weight on all possibilities is going to lead to the highest entropy possible, subject to the fact that we have n possibilities, and we have to place a proper probability distribution on them. And so a neat point that James makes is we can think about this as a codification of what like Laplace and Bernoulli, now centuries ago, were describing as the principle of insufficient reason. So if I have no information at all about what value omega is going to take on, there may be a sense in which the rational belief to hold is the one that maximizes the entropy, since I have no information, and that's just going to be a uniform distribution. Right? So probably a pretty intuitive idea. With no information, there's no reason to say 3 is more likely than 4. Everything should be equally likely. Okay, so now how do we incorporate information? So now this is where the James paper comes in, is to say, well, one way we can do that is if we can think about saying we want to maximize the entropy subject to some constraint. And so if we can formulate the information that we have as a constraint in our maximization problem, then this is going to become a really fruitful approach. So just to give you one example, maybe familiar to a lot of you, maybe not. First, just like cheating a bit and switching into continuous rather than discrete world. Suppose that the only information I have is that some variable, it takes on values on the real line, and the mean of that random variable is mu and the variance is sigma. So we can set this up as a like functional analysis maximization problem. Say, what is the density function, which maximizes the continuous version of entropy, which just like replaces sums with integrals, subject to the constraint that the mean of that density has to be 0 and the variance has to be sigma squared. And this happens to have a cool solution, which is that the answer is a normal distribution with mean, mu, and variance sigma. So this is like, very like not obvious before you write down the problem, like why isn't it exponential? Why isn't it Cauchy? Why isn't it something else? But it happens to be the case that the normal distribution is the answer to a problem like this. So good news here, again, this I think is another neat way to define rationality. It looks very different than Bayes' rule, has kind of a nice motivation to it. For some problems, it works out very well mathematically. But it's also maybe like as a social scientist, not the most useful definition. And that's why I think like most social scientists are totally unaware of this. I was unaware of it until a year ago, because it's not always the most natural way to think about the way that we get information in the social world, right? When I read a news article, it's not saying like the variance of the politician's corruption level is sigma squared. That's just not really a natural way to think about the kind of information that we observe in the social world. Okay, so kind of just like, so backdrop, hopefully getting set. There are these two approaches to rationality. Maybe not, both of them easy to implement, certainly mathematically. How to map that to reality, maybe a little tricky. But really stepping back, like the real bad news is that even if we can come up with some perfect way to measure like the correct rational beliefs, we're also generally going to be concerned that people might have incorrect or irrational beliefs as well. And so how should we think about modeling that? And so I don't want to cast this as like, oh, people out there are dumb. No one knows how to use Bayes' rule. What's wrong with them? Because in reality, the sort of forming correct or rational beliefs is an immensely challenging problem, right? So if I'm just even trying to form a belief about something pretty simple, like, did a particular present do a particular wrongdoing? In a sense, I need to bring an enormous amount of information to bear to know how to form a belief about that. I need to know everything I've ever learned about that politician. I need to know for every source of information I have, I need to have a belief about whether they're biased, whether they're accurate. Like how do I what's like the correlation between the reporting done by the Wall Street Journal and the New York Times, right? It's like when you think about what real inference problems look like, it immediately blows up and turns into a problem that like you maybe really need a supercomputer to solve. And so, then we can just go through a laundry list of all the reasons why it's really hard. I may not even know the set of all possibilities, right? I might not even know the set of all people who the president might do something corrupt with. So how do I form a belief about the probability that he did some shady deal when I don't even know what the set of deals he could have done is? And again, I could go on and on. The point is that sort of forming these rational beliefs is challenging, and so we should think about the constraints of people maybe not being able to do that fully correctly. And so the general kind of verbal idea that I want to say is a good way to think about biased beliefs is to say that in general, people are going to sort of care about accuracy. They're going to want to have as accurate of beliefs as possible, but they're going to sort of run into two problems. One is that that isn't their only goal, right? So it's not like when we go about our lives, our only goal is to have accurate beliefs, right? We also care about other things. We maybe care about how other people react to us. There may be some beliefs that we like holding more than others. And then we also sort of may make various mistakes in incorporating this new information, right? So it may be the case that there's like constraints on how we can process new information in various ways. And so we're going to want to think about formal ways to do that. Okay, so that's a lot of backdrop. So what am I going to actually try and do here? What's sort of new in this presentation? So I'm actually first going to start with bias beliefs, and I'm going to talk about why I think this information theory approach, which again may be like very familiar to many of you, but is not very commonly used, and certainly in political science, it's used a little bit in economics, to say that this is a really nice way to think about bias beliefs. So casting belief formation as a maximization problem is going to give us a lot of obvious tools to think about different kinds of bias beliefs. I'm going to talk about how I've applied this approach to what I think is the most commonly studied bias in the social sciences, which is motivated reasoning, or the desire to believe certain things. And then like along the way, and it'll actually kind of just pop up at the end, we're going to see that by working through this motivated beliefs problem, we're going to actually see a connection between this information theory approach and Bayes' rule. And again, I want to be clear, this is, again, not new to me. So other people have pointed this out as well. But I'm going to sort of show you a way that we can capture Bayes' rule by using these maximization problems. I see there's something in the chat. Is it worth me responding to that, or?
So the question is that I think this might be a question maybe to leave for the Q&A, but it's Simon said he's got a minor quibble. You've presented these approaches as alternatives, but doesn't Jaynes propose maxint as a solution to the question of how to select a Bayesian prior?
I maybe just don't know which paper you're referring to. But anyways, yeah, that's a good point. Let's maybe I think when you see sort of what's proposed here, it probably like corresponds to that as well. But yeah, so let's maybe hold that one for later. Cool. Okay, so the notation that I'm going to be using in this paper. So again, we're gonna think of a discrete state space. So we're going to be forming beliefs about some variable that can take on discrete n possible values. We could do this with continuous state spaces too. It's just the math is a little trickier. And so we're sort of let P be the set of proper probability distributions over this. At any time, individuals or subjects are going to hold a subjective belief, which is going to be some probability distribution here. And I'll often use a tilde to over the PR to make sure we know it's a subjective belief. I'm also going to take as exogenous for now some object that I'm going to call the objective belief, which you can think of that as like, in principle, if one were to process all the information rationally, and again, this can start to seem a little circular, but for now, I'm going to take that as exogenous and fixed, and then we're going to think about potential differences between this rational or objective belief and the subjective belief. There's also going to be maybe a signal and some updating of beliefs, and I'll give you some new notation for that later. Okay, so a little more information theory primer. Again, probably not new to most of you, but even if you know a lot about this, maybe good to think about how I'm going to be mapping these concepts to subjective and objective beliefs. So if we want to talk about bias beliefs, so remember the formula for entropy is just a function of P, it's just a function of one probability distribution. But so if we want to talk about bias beliefs, we're going to need to have some subjective belief and an objective belief. So first, just like before even motivating this, we can think, okay, well, maybe like, what if we take entropy, but we change one of the subjective beliefs to the objective belief, right? So unfortunately, this happens to correspond to like the second formula in any information theory textbook, which is called the cross entropy. And so hopefully I'm getting my terminology right here. We call this the cross entropy of P relative to Q. And so in thinking about bias beliefs, a way you might want to interpret this as saying, so if I sort of like subjectively hold belief P, but there's a real distribution Q, then this is going to tell us how surprised am I going to be on average if my surprise is determined by this log 1 over pi, if we move the minus sign. But the actual real distribution of events is going to be Q. So this is how surprised do I end up on average if I have an incorrect belief in some sense. And so you might think that, again, starting to move towards what can we do with maximization problems is to ask, now treating the objective belief as fixed, what's going to be the subjective belief that minimizes surprise, right? So like, what's the belief I can hold that will render me as least surprised as possible on average? And so, oh, I might have actually, I don't know if I just can't see it, or, oh yeah, it is at the bottom here. So fortunately, again, this is like a pretty straightforward maximization problem. The solution to this problem is to have the subjective belief equal to the objective belief. So you minimize your surprise by having this objective belief. So there's maybe one sense in which like biased beliefs are bad in that they give us unnecessary surprise. Importantly, cross entropy is not symmetric. So we have two arguments to this, but we could also swap this, and we can like average over the PIs and look at log QI. And so this might be like a little goofier to interpret, but it's going to be useful later on. That we can think of this as like, if I subjectively think that the distribution is P, but in the back of my mind, I like when I actually evaluate my surprise, I like know that Q is the truth. How surprised do I expect to be? So you can maybe think of this as like a measure of subjective surprise rather than objective surprise given an incorrect belief. And just so we can like say what is the belief distribution P that minimizes this. And so here the answer is actually different. Here the way you minimize subjective surprise is to think that the thing which is objectively most likely is going to happen for sure, right? So this is just like a linear function of PI. Linear functions always have corner solutions. So I'm just going to put probability 1 on whatever is most likely. And obviously, if there's like a tie, then there's multiple solutions. But if there's a unique thing which is most likely, we have to put probability 1 on that. Okay, so the final bit. So what I'm actually going to be using to capture the idea of people wanting accurate beliefs is to use what's called the Kullback-Leibler divergence. So this is used in tons of different scenarios. Really, the Kullback-Leibler divergence is just the difference between the cross entropy and the entropy. And so we often call the thing that we average over the reference distribution. And so we're going to call this, if we write it as the KL divergence from P to Q, we're averaging over QI of the log of QI over PI. And so a nice way to think about this in terms of subjective objective beliefs is if the real objective belief is Q, how sort of excessively surprised am I going to be, right? So remember, having the correct belief is going to minimize surprise. So this is saying how much extra surprise do I get above and beyond how surprised I would be if I had the objective belief. So nice thing about KL divergence, if P is equal to Q, it's going to be equal to 0. And then it's like, broadly speaking, increasing as the subjective belief gets further from the objective belief. So you can think of this as like a measure of how much we fiddle with our beliefs is the Kullback-Leibler divergence from the subjective to the objective. Right. So if we want to think about biased beliefs and we want to codify the fact that people want their beliefs to be accurate, we can think of that as they like want this KL divergence to be small. So a technical problem that arises is, remember, this KL divergence isn't symmetric. So it's not obvious like which way we should write our accuracy motive. Should it be the KL divergence from P to Q or from Q to P? So excuse me, if all we're trying to do is minimize the KL divergence, then this choice actually doesn't matter, because if no matter how we write it, the P that maximizes this minus KL divergence is going to be Q. Again, it's like very, very easy maximization problem to show that. The one I'm actually going to use, and if there's like any like information theory experts out there, it'd be like really useful for you to hear if you think what I'm saying here is kosher, is I'm always going to use the KL divergence from the objective belief to the subjective belief. Short version of that, version of this is like, we're generally going to be thinking of the subjective belief as the one that people genuinely hold. And so in some sense, it makes sense for them to average over the belief that like they think is reality. The kind of mercenary reason to do this is it's going to make the math work out way nicer, and it's just going to correspond to what I understand most of people in like statistical mechanics do when they're doing maximization problems like this. So again, if like that sounds crazy to someone who knows a lot about this, like it'd be really helpful for me to hear that. But for now, this is the version I'm going to run with. Okay, so how might we use this information theory maximization approach to get at a particular bias belief? So the main example I'm going to walk through is, again, what are called motivated, or in political science, we often call them partisan beliefs. So what we often mean by this is that when people are forming beliefs, they have what we might call a directional motive. They like to believe some things more than others, in addition to an accuracy motive. And so in political settings, this usually corresponds to something like, I want to believe that the politicians in my party are good. I want to think the politicians in other parties are bad. It's kind of a standard way this plays out. I don't know if there's any other political scientists here. There's a sort of a huge debate about whether this is a good explanation for things like polarization and for why people from different parties tend to disagree even about facts. Like, you know, did inflation go up under Obama's presidency? Republicans and Democrats will disagree about that. An important counter to the idea that this is just driven by motivated reasoning is that we can, like, Bayes' rule is very flexible, right? So you can often, for any particular pattern of Republicans and Democrats disagreeing about something, we can usually come up with some Bayesian explanation for that, right? Maybe they just like have different information sources that leads to different beliefs. And then if we see them like reacting differently to some news article, like, you know, news article says Trump is corrupt, Republicans say it's fake news, Democrats say like, of course, this is accurate. It's like very easy to come up with Bayesian explanations for, say, differing reactions to the same information. But so like in the end, there's like a lot of back and forth here. And I think there was sort of like no resolution to the question of whether different responses to information can be informative about motivated reasoning. So I'm gonna use this information theory approach to answer that question, and to preview, the answer is going to be no, that it's impossible to look at how people respond to information and see if they're motivated reasoners as formalized here. So let's again take any objective belief as exogenous. There is going to be a signal and some updating, but for now, just like Q is going to correspond to our objective beliefs. And suppose a motivated belief is going to solve an extended version of the kind of maximization problem I was just talking about, where there's going to be two components to our maximization problem. First, we want to minimize the KL divergence from the objective belief to the subjective belief. But then we're going to add this term where to capture the idea that there's some beliefs I like holding more than others. So if, say, state I is something I like believing, I'm going to give a high or a positive value to VI. If state I is something I don't like believing, I'm going to give a low or maybe negative value to VI. And so this is just going to capture the idea that I sort of like holding beliefs that put more probability on the things that I want to believe and not the things that I don't want to believe. So I could like get into more technical details here, but that's maybe I think a reasonable way to get at what people mean by motivated reasoning. Let's maybe skip over that. And so people who study motivated reasoning, again, are often looking at how we react to new information. So I'm going to like layer in a signal, which has a likelihood function f of s given omega, which could be like continuous, it could be discrete. It's going to be very flexible. All I need to know is the likelihood function. And so essentially what I'm going to do is I'm going to like think about, there's a Bayesian updating happening in the background. And then motivated reasoning is going to affect both the prior and the posterior belief. So in some sense, it's like a static bias, and it's like not how you incorporate the signal per se, but motivated reasoning is going to affect both the prior and the posterior. So here's a simple theorem that comes out of this maximization problem, which is that first, so we can take any Bayesian belief Q and any directional motive, which corresponds to how much I like each state. And there's going to be a unique solution to that maximization problem, where think of it as the subjective belief, ignoring the denominator for a second. The subjective belief is going to be equal to the objective belief times the exponent of this value function. And then we're just doing a normalization here to ensure that this remains a probability distribution. So just in words, all we're going to do is we're going to like upweight the things we want to believe. we're going to downweight the things we don't want to believe, but sort of the objective belief matters too, right? So it's always sort of like some multiplier of the objective belief. Here's a quick consequence of that result, which is that, so let's like take anyone who has an objective prior belief Q and a directional motive given by this vector V. Then I'm going to construct what I'm going to call the fully Bayesian equivalent, which is going to be someone who has no directional motives and has an objective belief equal to what I just calculated. Right? So think of this as the person who has an objective belief corresponding to the motivated belief of the person we started with. And what this result says is that those two people are going to react to any new signal in the exact same way. Right? So think of it as like someone starts with like a motivated prior belief that may have directional motives, they may be sort of biased for various reasons. But as long as they update by Bayes' rule moving forward, they're going to update exactly like someone who has no directional motives, but who happen to start with the same prior as them. So just to explain, to sort of unpack this a bit. So where I'm going with this, thinking about experimental work, is that there seemed to be like some view in this experimental literature that like, if we find the right clever signal structure, we can find a way to figure out if people are motivated reasoners. By like giving different information to people who have like different partisanship or something like that. So what this theorem says is that that's just like a fool's errand. You can never do that, because sort of like once we know what someone's prior belief is, maybe affected by motivated reasoning, they're going to react to new information in the same way, regardless of whether they came to that prior belief purely objectively or because they have motivated reasoning. So there's just no experiment we can design where just looking at how people respond to information tells us about whether they're motivated reasoners. Quick like side citation. So if you don't like the way I set this up, there's this like great paper by Guy Mayraz, which uses an axiomatic formulation and sort of comes with the same formula. Then another like important thing, which is going to prove really important moving forward when I start to get to this unifying different approaches, is that notice this like formula here looks a lot like Bayes' rule. I've just replaced the likelihood function with e to the power of the I. Right. So first, just in motivating reasoning world, I think this highlights a parallel between wanting to believe that something is true and having information which objectively indicates that it's true. So by this formalization, those two things have the exact same effect on our beliefs. And so that has this experimental consequence that makes it really hard to tell whether people are motivated reasoners, because I sort of can't tell if you disagree with me because of information or directional motives. And then just a final point, we can always like nest the correct belief here. Again, I don't know how people are interested in like, the broad experimental literature, so I'll go through this kind of quickly. Again, I think this shows that by this definition of motivated reasoning, a lot of the really prominent research designs just don't work for detecting motivated reasoning. Just to quickly say some things which I think are helpful. So there's some neat studies which try and manipulate accuracy or directional motives. So there's like a neat paper which shows that like really if all you do is tell people ahead of time like it's important to hold accurate beliefs, then that actually seems to influence how they process information. There's also a set of other results which I think are like also not really consistent with this version of motivated reasoning, where people might update more in response to good news in a sense rather than bad news. So if you give me information which says like I'm smart versus I'm dumb, I might update like a Bayesian if you tell me I'm smart, but not if you tell me that I'm dumb. And I'll like actually revisit this point a bit later on. I think you can, if you extend this definition of motivated reasoning to also allow people to differentially incorporate or remember signals, you can actually you can actually make a lot of predictions consistent with these results. Happy to talk more about that, but I think this is a bit more of like an in the weeds, like political sciencey econ debate. So I'll maybe leave it at that. But I do want to get at what I think is an important real world implication of this result, which is that I think it's very common when we see someone who reacts to some information in a way that like seems crazy or inexplicable to us, to say like, aha, like they must be a motivated reason, right? Someone who's really into QAnon sees January 6th and says like, oh, this must mean that like Q wasn't ready to install Trump as president yet, it's going to happen in a month. Like, that may seem totally crazy to someone who's not a QAnon person. And you may think like there must be something wrong with how people are processing information to interpret these events that way. But what this result shows is that that's not even like scientifically a correct conclusion to reach, right? If someone, reacts to January 6th in a weird way, like really that just means they have a different prior belief or a different likelihood function than me. And like they may, it may well be the case that their prior belief arose because of motivated reasoning, because of some other bias. There may be something wrong with how they process information, but there might also be something wrong with how I process information. So these kinds of disagreement, just like really all they tell us is that we have different priors and likelihood functions. And just, I think, lobbing accusations of like, you're biased, no, you're biased is just not very helpful. And so I think like a much more productive way to think about these kinds of disagreements, or whenever you see someone react to information in a way that seems wrong, is to like just first give them the presumption that they're a reasonable person who's doing their best, and try and think through like what set of beliefs, what prior belief, what understanding of what these different pieces of information mean might lead to them updating the way they do, right? And so even as like I am someone who like my like broad like post-tenure project in research is to think through the implications of biased beliefs. So in some sense, I might have like an incentive to want to see biased beliefs everywhere. But I actually think like both for the world and for our scientific understanding, it's better to always start with the presumption that people are like basically trying to be reasonable, and to only deviate from that when we have really good evidence. I just think that's like a broadly like the way we should think about people is to grant them good faith that they're doing their best. Of course, we often do make mistakes, and I'll talk a little more about some common mistakes that we do see, but I do think this is like the right way to start. So this might be a good place to pause if there's another question to answer now.
So the most recent question in the chat was just making a paper suggestion, I think, drawing a parallel between the motivated reasoning problem and its solution seems directly tied to this information theoretical bounded rationality in a particular paper. So that might be something.
Okay, great. Yeah. Okay. So yeah, we can talk about that later.
Yep.
Okay. So now, now let's start to veer towards like, how do we get Bayes' rule out of this information theory updating? And so mathematically speaking, this is really easy, because I already told you that this motivated beliefs formula is just Bayes' rule, where we replace the likelihood function with this exponent of the value function. Okay. So if we just, like reverse engineering want to derive Bayes' rule, all we need to do is put the log of the likelihood function where I put VI before. Right? So if we solve this maximization problem here, we are just like mechanically going to get Bayes' rule. So again, I want to like flag that I'm not the first person to make this observation. So there's this series of papers by Zellner. There's a physicist, I believe, Ariel Katica, who like has another axiomatic formalization for this. But just in terms of like my formalization, like why might this give us Bayes' rule? I'm going to be a little hand wavy here, partly for time, partly because like I'm still wrapping my head around this. But so let's like recall our general principle is that we want to be as uncertain as possible, subject to the constraints of the information we have. And so one way to think about, or just one way to rewrite minimizing KL divergence is maximizing the entropy of our subjective belief minus the cross entropy of the subjective belief relative to the objective belief. Or hopefully I said that right. I always get my terminology confused. So what happens when we solve this maximization problem? Well, like if we only paid attention to the entropy part, we would end up with a uniform distribution. If we only paid attention to the second part, we would put all of our weight on the most likely element. Remember, this was the maximization problem, which is maximized it, put probability 1 on the most likely thing. So we can kind of think of that as like, this is a force which gets us to put more information on the information that we have. And so, in fact, like another statement of the fact that minimizing the KL divergence from the objective belief to the subjective belief is in a sense equivalent to saying maximize entropy subject to the information we have. That like happens to give the same answer. And so now if we think of Q as the prior belief, and we're getting a new signal, now we're just maximizing a formula with three things. We have we want to maximize entropy, subject to the information in the prior, which we can measure with this cross entropy. And then sort of the analogous way to write the information from the signal is just the sum of, the probability of state J times the likelihood function of the signal at J. Right? So in a sense, we're just creating a parallel way to incorporate the information from the prior and the information from the signal. This maybe seems like a reasonable way to capture what James was getting at using likelihood functions. And again, mathematically, I just showed you that this is going to happen to correspond to Bayes' rule. So this is just in my head, how it makes sense that this kind of maximization problem is going to happen to correspond to the way that social scientists typically think about updating in response to new information, right? So we're broadly speaking putting equal weight on the desire to maximize entropy, the constraints of the prior and the constraints of the signal. Right. So first, again, just as a conceptual point, and again, how, it's certainly not new, how old this idea is, or how well known this idea is, I think is probably up for debate. But this notion that these are two separate ways of viewing of rationality, I think there's a way that we can combine them in a relatively simple formal framework. The bit that is more interesting to me is that there's a sense in which starting from Bayes' rule is not a very helpful way to think about biased beliefs, because all Bayes' rule requires is conditional probability and division. But so if we think about rational updating as the solution to a maximization problem like this, that opens up a lot of obvious questions of okay, what if we change that maximization problem? And so I showed you one example where we added something to the maximization problem to get at motivated reasoning. But we could also do lots of other things, what if we just change the weights that we put on these different things, right? So, implicitly in this formula, we're putting weight 1 on all three of these desires. And so what if we just change the weights on those? And so the neat thing that arises, I have the math of this and some backup slides if you want to see it, but what this produces is actually two extremely well-known empirical phenomena, which are called conservatism and base rate neglect. So it's not conservatism in the liberal conservative sense, but what this means is people generally underreact to new information. In situations where you can define the likelihood function in a concrete way, people tend to not update as much as they should. And so a way you can get that is essentially just downweighting this information from the signal. And you sort of get a formula which is actually consistent with a lot of regressions people run to test this idea. If you want to get at this base rate neglect, you want to sort of underweight the prior information. So you can get that as well. We can also think about confirmation bias in this setting too. So there's actually two ways to think about this. I won't go through this. I want to wrap up so we can get to questions soon. But so there's actually, I think, two ways you can think about confirmation bias here. One is that you just don't want to move away from your prior belief. The other one, which actually comes out of this motivated reasoning idea, is that maybe I'm just going to reject signals which would lead to less pleasant beliefs, right? And if I'm a motivated reasoner, I'm going to tend to believe things that I want to believe in my prior. And so rejecting things which disagree with my prior might actually be just rejecting things that I don't want to believe. And I actually think I'm a little biased myself because this sort of comes more out of my formalization, but I think there's actually very good empirical reasons to think that this motivated reasoning version of confirmation bias is actually a better way to think of it and more consistent with a lot of evidence. And then finally, we can think of a broad catch-all is that maybe just people have the wrong likelihood function. So there's this big literature right now, mostly in economics, and they call misspecified models. So what happens if people just have an incorrect view of how the world works? And so you can think about that in this framework as well. So just quickly, some I think conclusions of the formalization, which I've kind of swept under the rug here. I just wanted to give you a taste of it. So first, to be, not overclaim here. I'm guessing there's some people here who are experts on how the brain works. And I certainly do not think this is a descriptive model of how people form their beliefs. I do not think that people are solving, functional analysis maximization problems when they're deciding how to view the world. Rather, I think it's just sort of a nice way to collect a lot of different ideas into a common framework. Another bit which I'll kind of tease, I'm happy to expand on this when in our discussion, is a lot of biases which seem like they're not necessarily connected, can all arise from this framework if what people do is essentially put too much weight on the maximizing entropy part. Right, so remember, part of this maximization problem is maximize entropy. There's other stuff going on too. So if people put too much weight on maximizing entropy or not enough weight on other stuff, then that can produce a ton of different biases which we see experimentally. I'm just like throwing out all the names here, like partition independence, ignorance priors, compressed beliefs. I'm happy to talk more about the evidence behind all of these, but these are a lot of things which I think people have not necessarily seen as connected to each other, and they all come out of can potentially come out of just solving this maximization problem incorrectly and putting too much weight on the entropy term. And like in words, the way I like to think about this is essentially just like confusion. You can think of just putting too much weight on the maximize entropy part is like not really knowing how to incorporate all the information you have. And so as a result, you end up with kind of excess entropy, right? Or so it's sort of like hard to understand how to incorporate all the information. And that's going to produce a lot of these different biases. I think there's a lot of open questions here too. Can we like maybe estimate that, like excessive entropy as like a parameter which is maybe consistent to people across problems or consistent to problems across people? I think that's like an open question, which would be really interesting to explore. Another, I think, totally open question, which to be clear, some people have asked this kind of question before, but I'm not sure if this framework has something new to say about like why people have incorrect beliefs. Right. You might think there's a benefit to having overconfidence, maybe, or maybe I think the natural way to think about it in this framework is it might just be kind of like costly to try and incorporate all the information correctly. And so maybe we just rely too heavily on the maximize entropy part, just so we don't have to expend a lot of resources to think more. I don't think that's like a super novel idea, but this formalization might be a way to think about that as well. And I'm super open to other ideas or suggestions. So just to wrap up, I think this like entropy maximization approach is definitely underused in the social sciences. Some of you in other disciplines may be like looking at me like you're crazy. We already know entropy is great. Like, why have you not all been doing this before? So feel free to think that. In a sense, I agree. I think it's a nice way to combine different notions of rationality and a nice way to think about biased beliefs. And I hope that you agree there's a lot of research that we can do in this direction. And so with that, I'll stop and looking forward to the discussion. So thank you so much.
Yeah, thanks. That was really great. I think it's already inspired quite a few questions. I do want to just like pause, give you the opportunity if you need to like run to the bathroom or anything.
Oh no, I'm good. I got my water, I got my coffee, ready to go.
Cool. Yeah, so we'll jump into the Q&A. I'm just gonna go and I'm just going to allow everyone to talk and hope that
oh yeah, so actually why don't I now that I'm like looking at the Q&A, yes, so to Simon's question, right, so like I know particularly in Bayesian statistics this is often an approach people use in trying to determine like what the right prior is, right? So it's like when possible, you want to use a uniform prior. If you need to do something on the real line, people will like pick a normal distribution with like really high variance. But again, I think like what's I mean, not new, because other people have pointed this out as well, is this using the ideas of like entropy to also get to the updating part, not just setting the prior part. So it's a good question, but thanks. Yeah, sorry, I just like saw that one. I don't know, is it best to, I can respond to the written ones, or if people want to talk, however you want to run things.
Yeah, no worries. Yeah, I think Tomasz had two things that he added. Maybe he wants to say a little bit about his questions or comments. I guess they're more comments than questions, but seems like he might want to say something. So I'll give him a second to, I think he should be able to unmute now. Yeah, it may not be getting good sound quality from you, so Yeah, I don't. I can't understand you. I don't know if you probably can't understand him either, Andrew.
No, so yeah, I can't hear.
Um,
So I mean, I can. I mean, it looks like the verse point is just a reference, thanks. I'll take a look at that. Let me see if the second question has anything useful to respond to. Oh yes, is this the yeah. I have seen this paper, but I have not had a chance to read it closely yet. And I don't quite know how to make what to make of it yet. So
I'm sorry, can you hear me now?
Yeah, if you have any ideas, sorry, go ahead.
Yeah, we
sorry, can you hear me now?
Yes, yeah, sounds good.
Yeah, sorry about that. I had to fetch a headset. Yeah, so this is the like two remarks that I found interesting recently and seem related. So the Ortega and Brown have a notion of information theoretic bounded rationality, where when they look at the behavior of bounded rational agents, and they have like a concrete model, which is basically that the belief is not just that the belief that an agent takes is a solution to an equation which is very similar to yours. It's some expectation over the value of the belief minus scale divergence, where the scale divergence in their case is modeling the cost of obtaining information. So like an agent which has high rationality, which means low cost of obtaining information, might form like a high value belief, while the agent with high cost of information may not. And I don't see the link directly to your to what you were saying here, but the formula is exactly the same, and the solution is also this Boltzmann distribution, which also like appears all over the place in free energy and recently active inference. And they are also why I thought it might be related and interesting to look at is because they also don't claim that the bounded rational thinker is solving any kind of equation that like explicitly creating this subjective belief minimizing scale divergence, but that they have few examples where this can be like a very natural thing to arise. For example, when the bounded thinker is doing rejection sampling, just like taking an option, seeing the value, and rejecting the value with some, or accepting the value with some exponential function of the value, and their strictness or demand. Then what you see is actually like the sort of from the outside you will see this optimal solution to the scale divergence minimization problem. So yeah, so that was I thought that might be related, so I noted it down.
Yeah, that sounds really useful. And yeah, so the I don't know if anything was circulated. Right, so in the motivated belief paper, it's like the bit I was saying about confirmation bias, I think actually relates to this a bit, where there's a sense in which people are like deciding what to accept or reject as they get new information. And so it sounds like there might be a connection there too. So yeah, I'll definitely take a look. Thanks.
And I'll quickly go over the second comment. I'm not into full detail, but it seems that the wishful thinking, or at least like in the free energy framings and the active inference, it seems that like that wishful thinking can actually be optimal. And one concrete, very simple, but actually very like neatly written down example of a theorem that says if you compare a utility maximizer, who is some distribution over the state of the world, and like some belief about the state of the world which is unknown, and takes an action that maximizes expected utility. If you replace this with a wishful thinker, who is not just selecting action, but it's also selecting a subjective belief, so that the utility is good under the subjective belief of the action, but minus a scale divergence of the belief from the real world, this is also picks the optimal action. And so this is an example for me of like possibly like a bigger cluster of theorems and results that a certain well-executed wishful thinking can be optimal, And I'm wondering if you have if you have something like that, and like if you're encountering this in the research where you could see that under certain assumptions, having a bias can be optimal if if somehow you assume that the rest of the system is not too skewed or something like that.
Yeah, so thanks. Actually, this paper, it's like I think like the final version of this paper like cited me in a footnote, and so I got a Google Scholar update, and I was like, I need to read that paper, and I haven't done it yet, so that's a good reminder.
Oh.
Yes, but so on the broad, I think that's like a really interesting broader question of like, can these beliefs be good? So there's one. This is not an original argument to me for sure, but I think there's like an argument that this is a driver of overconfidence in the sense. So I mean, this is kind of, I think it's like a Trivers argument basically, that like if if in some sense it's easier for me to convince people that I'm good or strong or smart or whatever if I truly believe it, then there might be kind of some value to skewing that information. And so there are some papers I think that like model that trade-off where it's like if I have biased beliefs, I might make worse decisions for myself, but it might like lead other people in a game theoretic setting to be more favorable towards me. So I think, that to me, that's like a pretty plausible hypothesis. I don't know if there's like great evidence for or against that.
Thanks. Yeah, if you ever I haven't seen this in context of game theory, like convincing others. I mean, that makes perfect sense. The thing I was citing was just like for subjective decisions, and even that it can be optimal even there. If you have a reference, can you just maybe drop it later into the chat?
Yeah. If you just email me, I'll put it in.
Cool, thanks.
Another, actually, I just realized I may have not included a citation on the slides, but in economics, the most well-known work on motivated beliefs is by Benabou and Tirole. And so they actually are looking at just individual decision problems. And to them, there's a lot of papers that do a lot of things in that tradition, but like the core one, which I think is most widely known and influential, is essentially that it's like motivated beliefs are solving another problem. So if you have time inconsistent preferences, and so you are like more apt to, or it's like, I'm not going to like do a hard task unless if it's going to be costly today, even though if I had like proper time discounting, I would do the costly thing today. That like being overconfident about my ability to do that task might solve the time inconsistency problem, right? So you can think of it as like, it's like one bias correcting for another. And I think there actually is some, so like it always like struck me as like kind of a narrow explanation for overconfidence. I mean, it's like totally plausible, and I think there's some evidence for it. And they're wonderful papers. I don't mean to knock those papers, but yeah, that's like another reason why you might see this in just a single person decision problem.
Yeah, thanks. I'll let the others have their.
Yeah, but thanks for the references.
So Sahil asked a question. I don't know if you're able to talk, if you want to say a little bit more about your question, or I can just read it. I'll give you a second to unmute if you're able to.
So I'll just read the question, and then well, yeah. So isn't most of the reason to use likelihoods instead of attempting to get it a posterior directly? That likelihoods often come from objective, independently verifiable processes. So let me see if I have a response to this. Let me know if this answers your question. So like there are some times when the likelihood function is clear, and so what a lot of the experimental work does is essentially try and do this, try and set up a situation where the likelihood function is objectively true. So there's a lot of classic experiments that do things where it's like ball and urn type experiments, where it's like, this is either an urn with 75% red or 25%, or sorry, 75% red or 75% blue. I'm going to like show you one ball and then see how you update. So that's a scenario where like there is a correct likelihood function there. We could all might have to like sit for a second and sketch it out, but it's like not a super hard problem to figure out what it is. And so like a lot of the evidence about base rate neglect and conservatism comes from experiments like that, where the likelihood function, there is an objective likelihood function. There's some other more recent work which does like a little more natural stuff, where it's like at least a natural belief to start with of, so you know, did unemployment go up or down under Obama? And then you tell subjects like, you know, I'm going to give you a signal which is going to be correct 2/3 of the time and incorrect 1/3 of the time about that. And so that also like implies a likelihood function which you can use as a benchmark to figure out how Bayesian should update. I would say that, like, again, I don't know how interesting like the weeds of experimental designs are, how interesting that is to people here, but like the challenge there is that you have to like assume that people like believe the experimenter. That's like the key assumption there, that like they think that you know, when you put them in a lab and like give them this weird question about balls and urns, that you're telling them the truth about the data generating process, and that people understand it. So I think there's like a lot of debate about like if we observe, say, underreacting to new information, like does that mean people just don't believe us? You know, I mean, this is, you know, there's like bigger debates about should we do deception in experiments, but like it may be a total reasonable model in someone's head to say like, yeah, there's a 50% chance that the experimenter is just messing with me, and like if so, that affects how they should update. And you know, we maybe can't observe that. So yeah, so certainly like there are situations where likelihoods can be independently verifiable, but I think in most real world situations it's much harder. So hopefully that answers your question.
I'll give him a second. I think that he's probably maybe not able to talk. I think he's been not able to talk on a talk before. So yeah, Simon's asked a few questions, I think, and I'm pretty sure Simon will probably want to say some things about his questions. So yeah, there you go, Simon.
Oh, thanks. Sorry, I've got a bit of a cold at the moment. So this was a question about the free energy framework from cognitive neuroscience, which goes under a variety of different labels and names. Most notably at the moment, predictive processing. I guess I don't know. Are you familiar with that?
No, so I know nothing about this. So this is my chance to learn. Yeah.
Okay, so this is a like a this is now has been for a while quite a trendy approach to cognitive neuroscience, and the idea can be thought of. I think the idea can be thought of as follows. Instead of assuming that the beliefs and desires are different sorts of things, the core explanatory concept in the predictive processing framework is of something that they call a prediction, but it's actually just it's a probability function over outcomes, and that, depending on how things work out, that can either be interpreted as belief-like or desire-like.
Desire-like?
Or desire-like, yeah. Okay. So the idea is that the parameters of the system change so as to minimize the discrepancy, and it's basically like a KL divergence between this so-called prediction and the actual signals that are coming into the system. Whether you're thinking about the system as a whole, those would be like the sensory signals, or particular part of the system, and then it would be, you know, the bits that are feeding into it from other parts of the brain and body. But the core unifying idea is that this divergence or discrepancy can be minimized in two different ways. One of them is by updating the parameters that encode the so-called prediction, but the other way that it can be minimized is by actually changing the world so that the signals that come in are more like what you were expecting. Does that make sense?
Yeah. So, I mean, so like yeah. I mean, so one way to think about that, I think, in this maximization framework is like you can also take an action which affects Q, which affects the objective distribution. Maybe, you know, some costly action or something like that. Does that?
Yeah.
I mean, I haven't actually like fiddled around with any examples of that, but that seems like something which is could be mathematically tractable and
So,
could potentially get at that idea.
Yeah, so there's a lot of information theoretic work around it. And it's claimed to unify all sorts of things from cognitive neuroscience and physics and goodness knows what. But I mean, one of the things that I find attractive about it is exactly that it allows for these, as it were, you know, mental representations which are somewhere intermediate between beliefs and desires. And so that so one explanation of motivated reasoning, I guess, that might come from this way of thinking about things would be to suppose that what you're trying to do is actually, you're trying to change the world to make the things that you prefer come true. And that requires you to hold certain of these so-called predictions constant. Because if you change your internal variables, then you're just adapting to the external world, and that's not the whole of what you want to do. So from that point of view, like within this framework, the idea that, you know, when you're hungry, you want a you know, you have a high motivation to eat is just cashed out as, well, when you're hungry, you have a very high, you predict with a very high you know, probability that your hunger is going to be you know, is going to be relieved. And you don't have a lot of, you can't modify your internal variables to change that prediction. So when you're operating correctly, the reduction of divergence from that prediction has to come from your actions on the external world. And you can imagine that if there's some weird sort of emergent distributed way that all these things are balancing out against each other, it might sometimes be quite efficient to have things that look like motivated reasoning, because it's just kind of cheaper to do things that way than to do the bookkeeping of trying to figure out, you know, which beliefs you can actually change and which ones you can satisfy by changing the world to make it work. I don't know, sorry, but does that make any sense at all?
Yeah. I mean, so I'll maybe just, you know, give a couple reactions. So I think it actually might relate a bit to the like Robeson Steiner paper that Tomas was pointing to as well. I mean, so I'll just say I've done one thing I like totally chopped out of this presentation, so I wouldn't talk forever, is I mean, so I've also done work that does incorporate this into like models where people also make choices, where they make choices basically given their subjective beliefs. So there's like a natural, I don't know how much game theory people know here, but you know, our like standard solution concepts within complete information say that we maximize our expected utility given our beliefs, and our beliefs are like correct about both about the world and what other players are going to do. And so there's like a natural extension that to say, okay, well, what if people, you know, maximize their utility given their subjective beliefs, given this motivated reasoning process. So I've written a couple more like kind of standard political science papers that build on that idea. But I will say, like, I'm not sure it really, the way I've approached that would really be satisfying given this approach, given the ideas that you were throwing out, because like, in a sense, I'm treating them as like separate problems, or my co-authors and I treat them as separate problems. It's like, there's the belief maximization problem, and then there's the behavior given those beliefs. And it sounds like some of these ideas might give some more interesting ways to think about those interacting. a little bit more, which, you know, from an analytic perspective might be a bit harder. But yeah, that sounds like a potentially fruitful direction moving forward. Because again, I'm just like, it was the simplest, you know, I'm like trained as an orthodox game theorist. So like the easiest thing for me is to say, how do I take standard game theory and like tweak one thing? And so the one thing to tweak is just moving to these subjective beliefs. But there might be like really interesting stuff that we could learn from trying to look at these more general principles. So if you have any like citations along those lines that look relevant, it sounds like they're, you know, using similar ideas. So I'd be happy to take a look at that.
Okay, cool, thanks.
So TJ has a question. For some reason, they are appearing as Nora. Don't know why, but yeah, TJ, do you want to ask your question?
Hey, yeah. Why is this happening? I don't know. Okay, so my question was, I think, like related to the answer that you gave to Tomasz on the game theoretic stuff. I think I think like a lot of times beliefs also have like conative or desired like aspects to them. In the sense that like it's not just that like your belief is probably just a separate state and then you have desires, and then like in the standard story of rationality, you have beliefs and then desires, and then you like form intentions or decisions out of those things. That like often like beliefs themselves contain like things like self-fulfilling prophecies, like things that if you believed were true, then they would come true. I think the most common example of this would be something like, if I'm in and this is not so much about like trying to convince other agents, but like if I'm in a prisoner's dilemma, and if I believe that the other party is like going to cooperate, then if I believe that like if they are the kind of a agent, or like I'm the kind of an agent that when the other party cooperates, I cooperate or something, then there's a sense in which this belief itself unfolds in reality, in the sense that those agents will cooperate and not defect in the prisoner's dilemma, right? And so there is a sense in which like it seems like an important part of like some social systems that we sometimes hello. Am I still audible?
Yeah, can still hear you.
So I was saying that like like it seems like for some social processes or some social phenomena, it seems important that like what people believes also has like like the self-fulfilling prophecy sorts of aspects to it, that beliefs are not entirely disembodied observations on the world, but they are often like in engagement with the world or something. Does that make sense?
Well, yeah. So maybe so let me know. So tell me if this seems like a codification of the idea that you're proposing. So like, yeah, let's say, you know, I can have like incorrect beliefs about the nature of the prisoner's dilemma or something like that, which lead me to think that cooperation is optimal. And my partner knows that I have those beliefs. I guess I'm trying to think of like why that would make my partner cooperate too, is maybe a sticking point. But you know, so there may be some reason why, like, I don't know, maybe I self-persuade them to believe that as well, that like I mean, I think you need like other layers of I need an incorrect belief, and my incorrect belief needs to also shift the beliefs of my partner. Maybe, I don't know. Does that seem, maybe that's not what you're getting at.
I think like it's interesting that like you're already presuming that it's an incorrect belief. I think it's probably a correct belief that if everyone believed that the Pareto optimal thing to do in a prisoner's dilemma is cooperate, and therefore they should cooperate, then like they would not fall into like Nash traps or something. And one could prove it that like if like you have two agents who can all ascertain the following two statements about each other. One is that if the other agent is the sort of an agent that would cooperate if I cooperated, if you could prove this about yourself and about the other agent, then they would end up cooperating. And in some sense, my claim is that like a lot of things that a lot of like social trust operates like this, that actually you can incorrectly see prisoner's dilemma in life, in social life, where maybe the more constructive approach is to see it in another way. And there's a sense in which like neither of those frameworks are like objectively true, but like seeing through one leads, like if when everyone sees it through something like in another lens, it leads everyone to cooperate. Whereas like if everyone saw it through prisoner's dilemma, it would lead everyone to like defect. And so in that sense, like even like how we form beliefs ends up influencing what sorts of actions we take, even if like we even if we like separate the question of like preferences and stuff aside. Does that make sense?
Well, yeah, so maybe I'm like still have too much of a like residual orthodox game theorist in me, in that, so like the obvious question that raises to me is like, okay, you know, imagine we propose some form of equilibrium, kind of formally define what we mean by that, where like collective beliefs that cooperating is going to make people better off, or like if you know others cooperate, I'm going to cooperate as well. You know, leads us to cooperating in a prisoner's dilemma. Like, what's to stop someone from like flipping to the other belief that like, oh no, I can actually defect and exploit these people from that proposed equilibrium. So it's like what sort of makes it all hang together, I guess, is my question.
Right. So I think that's like in my mind, that's maybe like a separate question, but maybe it should not be, of like social robustness, where like are the number of agents which are flipping a sufficiently minor like fraction of the overall population that, I don't know, like there's some work in like sociology of law that like how like as long as like the deviation from law is minimal, you can use reputation systems, etc., to like actually still like preserve the rule of law or something. And I'm thinking like something like that, like, but that seems like a slightly different question of how certain equilibria are preserved to be robust under multi-agent settings. But the question of how did this equilibria actually even got selected has something to do with how beliefs are formed in the agents, is the mechanism that I'm trying to point to when we are thinking about like beliefs in this manner.
Sure. So maybe maybe an idea that might kind of link these is so like typically you know, again, in like orthodox game theory world, we generally distinguish between like beliefs about parameters and beliefs about what other players are going to do.
Right.
So if we're in like a game with multiple equilibria, which it could be infinitely repeated prisoner's dilemma, it could be a simple coordination game. Like there could we could also think about like motivated beliefs in conjectures about what other players will do. And so you might think that like, you know, the way, so an example I love to give is like, so consider a game where we both simultaneously throw up 1 or 2, and if we put up the same number, like someone pays us that amount of money. So this, you know, to like non-game theorists, this seems like the easiest game in the world. Like, of course, we're both going to play 2, but you know, by the standard Nash analysis, that game also has a Nash equilibrium where we both play 1. Right. And so, but you could think that maybe like the reason we like get out of that is if we have like optimistic beliefs about the behavior of the other player, then that can be kind of self-enforcing, right? I'm just going to like have the optimistic belief that like, of course, my partner's not an idiot and wants $2 more than 1. And so we, in a sense, like optimistic beliefs could serve as the coordinating device in order to get to the better equilibrium. Is that maybe
yeah. I think that's roughly like what I was trying to get to, that like like there is a difference when like we are having beliefs of this sort, because like unlike like beliefs about the objective world, where the objective world is not trying to have beliefs about us, but like when we're talking about like beliefs about other agents, and those agents also have beliefs about us. There's like sorts of different feedback loops that can appear, and like that can add like some sort of like self-fulfilling nature to some of the beliefs or something.
Yeah. That's a nice idea to think about.
So are there any other questions for Andrew? If not, I have just one basic one that I'd like to ask.
Sure.
So I was sort of at one point you talked about like the problem, it's like just a general modeling difficulty of the fact that if you're like carving out a possibility space for different people for a person's beliefs, there's just too many possibilities to compute. And so I was just wondering if there's any work, or if you're doing any work, or you're familiar with anyone doing work in political science or economics where they might be looking at beliefs at different levels of abstraction. And so like looking at how like beliefs at higher levels of abstraction are like constraining lower level beliefs. So for example, like if I believe that, you know, I think you used the QAnon example. Like if I believe that Trump is going to be re-elect, you know, put back into the position of being president, there might be like a multiplicity of ways that I could go about doing that. And so I was just wondering if that might be like a helpful approach, but I'm sort of imagining the modeling complexity there is pretty high. So yeah, I was just wondering if you're like familiar with anyone doing this sort of thing, or if you're thinking about this sort of thing.
Yeah, so something I am working on, and tell me if this, you know, does or doesn't get at that. So this is some work with it's like Don Moore and Ned Augenblick and Matt Backus, who are psychologists and economists. So we have this like very simple like 5-page paper, which is on my website, and it's actually referenced in the one of the papers I was building my talk on, but I like chopped this out. Is so like a simple thing to ask is like, what if people just can't think through all of the states? Right. So like, you know, maybe like, oh, capital omega is a really big set, which is like too much to like think about assigning probabilities to all those. So there's like a couple ways to think about that, both of which lead to the same answer. There's like a non-information theory way, which is just like, suppose that like all the things I do think about, I think I have like the correct ratio of probabilities between them. The information theory way to think about it is I'm going to solve this maximization problem on a constrained set where I set the probability equal to 0 for anything I don't think about. So those both actually produce a really simple formula where basically like think of it as like the probability that you would assign to the stuff you don't think about just gets like redistributed and everything else gets inflated upward. So that like either approach leads to that solution. It's like mathematically quite nice. And so we have our short paper like points out there's like a fair amount of evidence consistent with that. Then we're also working on this one is like literally very in progress. So there's no draft for this yet. But like another way to think of that is that maybe it's not that I don't think through all of the possible outcomes, but I don't think through all of the possible like models of the world that would produce different predictions. Right. So another way to think of that is like whenever I want to assign a probability distribution to something, I kind of need to make some assumptions about how the world works in order to do that. And there's a lot of different models. There's a lot of different assumptions I can make. And so maybe what people do is they just like pick out one model and they form their beliefs given that. Okay. And so we're showing in that paper, and we're hopefully going to have some initial empirical evidence, like observational evidence consistent with the model, and we're hoping to do some experimental work. Is that like first, so that like leads to overly precise beliefs. So in general, people are going to put too much probability on their most likely event. In general, they're going to have like another way to think of that is like they on average have too little variance in their subjective beliefs. So they're going to like, or you can think they have like tighter confidence intervals than they should is another way to think of that. So we're working through that idea that's another way to like, what does it mean to reduce complexity? Well, there's like a lot of random variables out there. Maybe for a bunch of them, I'm just going to like fix them at the most likely value and go from there. We think this seems to be consistent with a lot of evidence, but it'll probably be another 6 months or so before we optimistically another 6 months before we have a draft of that. So I don't know. Hopefully that maybe kind of gets at what you're thinking, and if not, happy to have other directions to pursue.
Yeah, I think that's related. What was the first paper you mentioned?
Oh, so it's on my website. It's called I think it's just called Constraints on Thinking Cause Over Precision. And I don't know, well, we're not sure. Basically the second paper I started describing, we view it as kind of like an improved version of the first one with a new co-author, and so we're not sure what we're going to do with the first one. But for now, it's just like a very short, easy read. They got desk rejected by a lot of journals, and so then we like decided to try something new. But if nothing else, I think it's like a neat little paper.
Yeah, cool. Yeah, no, that was a great talk. It got me thinking about a lot of different things. It's like really interesting material. I want to give anyone else an opportunity to ask, and if they've got any like last minute question. Otherwise, yeah, thank you for joining us.
Yeah, thanks for all the questions, and it was fun to talk to all of you. And yeah, please do follow up if you have any other questions or citations or other stuff I should be reading. I'd be happy to see that.
Yeah, cool. Appreciate it.
All right.
Thanks, everyone.
Yeah, thanks so much.